Okay, lads, 2015 titration example. So what titration is in a nutshell is a method for us to find out the concentration of, say, for example, some acid. Trying to find out its concentration. It's of unknown concentration. So we use something of known concentration, in this case a base of known concentration, C of known C, and then we will use some indicator, some kind of litmus test to find out at what point does this acid become completely neutralized, right? So basically, if we have a base of known concentration, we'll have this litmus test, and at an endpoint, this paper will change color. Some kind of indicator will change the whole color of everything, so we'll know the acid's been completely neutralized. Okay, so we'll measure what volume of the base was required to completely neutralize this acid. And then with the concentration of this base and its volume, we can basically find out the concentration of this acid. So it's basically just a method of finding out the concentration or volume of one thing by using something else of known concentration. Okay, so let's try to do this question. It says that we have a certain fertilizer that consists of 92% ammonium chloride. Okay, a sample of mass X grams of this fertilizer is dissolved in 100 cm cubed of a 0.1 mole per dm cubed sodium hydroxide solution. The sodium hydroxide is in excess, right? So we have a full balanced equation. We know that this NaOH is in excess, so whatever number of moles we find from doing V times C here isn't applied. We can't really apply it across this whole equation because NaOH is in excess, right? So we'll have to come up with something else when the time comes to that. So the first question asks us to calculate the number of moles of sodium hydroxide in which the sample is dissolved. Okay, so this is pretty straightforward. We have V equals 100 cm cubed, which is basically 0.1 dm cubed, and we have C is equal to 0.1 mole per dm cubed. Okay, and that obviously gives us N is equal to C times V, which is equal to 0.1 times 0.1, which is equal to 0.01. Okay, mole. Now that's the total initial amount of sodium hydroxide present. It's the total initial amount, right? So some of this is going to be used up and some of it's going to be left in excess. Cool, let's carry on reading. So it says, during a titration of 25 centimeters cubed of this excess sodium hydroxide, okay, it is titrated against a 0.11 mole per dm cubed hydrochloric acid solution. Okay, and then it says at the end point it is found that 14.55 centimeters cubed of this hydrochloric acid was used to neutralize the sodium hydroxide. Okay, so we have a full balanced equation. Everything here is 1-to-1, right? Which makes it very easy. But you could have different molar ratios. And it doesn't really complicate things that much. I'll show you how it actually comes in. Okay, so we have this little formula, which is concentration of the acid multiplied by the volume of the acid over the concentration of the base times the volume of the base is equal to Na over Nb. Okay, now Na and Nb is basically the molar ratio of the acid and the base. So our acid in this case is HCl and our base is NaOH. So we know it's basically just 1-to-1, which is essentially 1. Okay, so let's see what else they gave us. They gave us that the concentration of the acid is 0.11, and they gave us that the volume of the acid used is 14.55 cm cubed. Okay, well that's cm cubed, so we got to convert this, and that's 0.01455 dm cubed. Cool, right? So we have concentration of the acid and volume of the acid. And what do we want? We want the concentration of the base, the unknown thing, right? And we do have the volume of the base actually. So the volume of the base, they said, was 0.025 dm cubed. Cool, right? So we have Ca, we have Va, and we have Vb. Ca, Va, Vb. And what do we want? We want Cb. Cool, right? So we can go get the concentration of the base. And that is going to be 0,11 times 0,01455 over CB, what we want, times 0,025, and that's going to be equal to 1. That gives us CB is equal to 0,025 over 0,11 times 0,01455. And that's going to give us CB is equal to, CB is equal to 0,064 mole per dm cubed. Okay, now to find out what was actually, what number of moles was actually in excess, because what do we want, right? They want us to calculate the mass X in grams of the fertilizer sample used. They want us to basically calculate M for NH4. Okay. Now, in order for us to calculate that M, we need the N here, but not just any N, the N that's actually been reacted with, right? Not the N initially, not the N in excess, but the N that's actually gone through the reaction. So we know that we've got 100 cm cubed of this NaOH, right? So we have the concentration of it. If we multiply this concentration by 0,1 dm cubed, then we're going to get the NaOH that's actually been left in excess, right? Because we have the concentration and they tell us that it's dissolved in this 100 centimeter cubed sodium hydroxide. So we can go get N of NaOH in excess in 100 cm cubed. Right, and that's going to be N is equal to C times V, which is 0,064 times 0,1, which is equal to 6,4 times 10 to the minus 3. Okay, so that's the number of moles we have in excess. So the number of moles that we actually have reacted with is going to be equal to the initial amount we had, 0,01 actually, and we're going to minus this, right? So N of NaOH reacted is equal to initial minus excess, and that's going to be equal to 0,01 minus 6,4 times 10 to the minus 3, and that's going to give us 0,003598 mole. Okay, so now this is how much of NaOH has actually been reacted. Now this helps us because now we actually have this N that's been reacted, so we can come back to this equation and actually find the number of moles of NH4Cl, ammonium chloride. So we can see the molar ratio is just 1 to 1. So we know that N of the ammonium chloride, which is NH4Cl, is equal to, is equal to 0,003598 as well. Okay, so from here we want to find out the mass of this NH4Cl, right? So that's going to be M is equal to N times big M, so that's going to give us 0,003598, and then the molar mass of NH4Cl is 53,5. Okay, and that gives us a mass of 0,192 grams. Okay, so now this is the mass of NH4Cl present, right? But they tell us that this compound X, this fertilizer X, is 92% ammonium chloride, right? So it's not 100% ammonium chloride. So we found out that 92% gives us 0,192 grams. So if it's got another whole 8% of impurities, we're trying to find out what it is at 100%, right? So a way to do this is we just have to multiply 0,192 multiplied by 100 over 92. Okay, and this is going to give us basically 100%, and that's equal to 0.21 grams. Yeah, this is a pretty tricky example, I ain't gonna lie. But yeah, I hope this makes sense. Most important thing to take out of it is the use of this formula. Okay, so basically if we had an acid to base molar ratio of 2 to 1, then you'd actually sub in 2 and 1 here, and then you'd calculate your unknown. So yeah, cool stuff. This is basically a titration in a formula. You can see, like, if we have something of known concentration and known volume, and we can basically use it to find out an unknown concentration, right? That's because they completely neutralize each other. Okay, boys, good luck.